Hi, in this video we are going to be graphing the quadratic. So we've been solving quadratics, and so we have first we let's begin with this. A quadratic had the general form of ax squared plus bx plus c, and we began by factoring these. Then we said, well, what if it's ax squared plus bx plus c equals 0? Well, then what we did is we solved. Oops. Then we were solving quadratics. And today we're going to look at what happens when we have the form ax squared plus bx plus c equals y. And in this case, we are going to be graphing quadratics. And you might ask, well, why do we replace the numbers with the letter y? And the reason is that ax squared plus bx plus c equals y describes some kind of relationship. For example, it might be the cost, a cost or a profit equation for a company, for x is the number of units sold and y is the amount of revenue that's generated by the company. And actually that's a common one that you might see in an economics class. A quadratic also represents the trajectory of anything that is thrown, whether it's a bullet that's being fired from a gun or a ball that's thrown. That's described by the parabolic motion. So that's why we graph it, and what we're going to do today is see how to do it. So here's how we do this. If you're not sure where to begin with a graph. We're going to make a graph, and we're even going to review a bit of how to make a graph, or how to graph. So I'm going to make a graph here. That looks about right. Now remember, right in the middle is, well, let's do this. This horizontal line we refer to as the x values, and the vertical line are the y values. And if I want to talk about any point on the graph, it's called an ordered pair. So let's do this. Any point is called an ordered pair. Okay? For example, well, let's put some numbers on here. Right in the middle there is the point x is 0 and y is 0, and it's always x and y. That's this middle piece. It's also called the origin. So let's see, we could have x is 1, here's a 2, 3, 4, and then let's go up here for y. We have 1, here's 2, 3, 4, 5, 6, 7. Now, if we count down, say we're here at x, let's do this. Say we're here at x is 4. So if we count down from 4, we go 4, 3, 2, 1, 0. And then if we go to the left of 0, we have our negative value. So this would be -1, -2, -3, and so on. And these graphs, sometimes you'll see arrows. It means they just continue on forever. You can always just keep extending it until the end of your paper. So let's graph the most simple parabola the simplest quadratic that you can. And that's what we're going to do. We're going to graph y equals x squared. So if you're not sure what to do, we're going to make a table. Or you might hear it called make an XY table. It's a good way to track. Now, So we'll make a table. Let's see. Move this up a little bit. We'll have x values and y values. And what we do is we just start picking values. So for example, if x is 0, then what we do is we go, well, y equals 0 squared. Well, that's just 0. Okay, so now let's do another one. What if I did 1? What if x is 1? Well, then y becomes 1 squared, which is 1. Let's try 2. So then that becomes y equals 2 squared, which is 4. We'll try one more here. 3. Y equals 3 squared, which is 9. But that's going to be a big one on our graph. Let's just graph what we have so far. I'm going to graph these in another color so we can keep track. So for example, the point, the point 0, 0 is right there. The point 1, 1 means you go over to x is 1, and then you go up to where y is 1, and you put a dot. So the next point says x is 2, so I go all the way over here to 2. And then it says go up to 4. Well, 4 is way up there. And so where those meet is where I put my next dot. So there's a dot. My next one says 3, 9. So I go all the way over to the 3, and I go up to 9. And notice 9 is actually above the y. 9 would be up there. So then, now you don't have to put the dotted lines. I'm doing this so that you can see and track how we get to each point. Now notice that if I tried to make these a straight line, for example, my program has this function that if I was to start at 0, 0 and make a curvy line and hold it at the top point, notice that it straightens it out and it doesn't pick up those middle 2 points. So clearly a line is not the right choice. This one actually has a bit of a curve. Curves here, here. It's getting really steep, and actually it curves up like this. All right, now we could stop there, but there's a bit that's unresolved. What about over here? What happens in the negative values? Well, let's continue with our table. For example, what happens to just immediately to the left of 0? Well, that's where negative 1 is. So if I put negative 1 in for x, I get y equals negative 1 squared, but that's 1. If I try negative 2, that becomes y equals negative 2 squared, but that's 4. Wow. Those are positive. So wait, let's try one more. How about negative 3 for x? So y becomes negative 3 squared, but that's 9. Wow. All right. That's sweet. That's kind of unique. When I put the negatives in, it seems like it's going back up, not down. So let's try negative 1. I'm up at 1. So if I go over to negative 1, y is 1. So where those meet is where I put my next dot. The next one is negative 2, 4. So if I go over to negative 2 and then up to 4, I have my next point here. And then the last one is again up at 9, is way up there. And I go up from negative 3 to the 9th line or level. And there's negative 3, 9. And again, you can see it's not going to fit a straight line. And it makes this curving motion again. As a matter of fact, it looks just like what we did. And it goes past that. So a couple of things. One, this shape is called a parabola. And this is called a parabola. So in this case, the lowest point here, the lowest point lowest, and some parabolas can actually go down, so the lowest or highest point of the parabola is called the vertex. It's called the vertex. So in this case, the vertex is at 0, 0. Okay, one more thing. I'm going to need another color to illustrate this. I like this magenta color here. So notice that actually a parabola has this interesting property that it creates a mirror image of itself. So this purple line, or this magenta line that goes, in this case, it's right along the y-axis. If I was to have this as a piece of paper and fold the parabola, or fold the right side all the way over, it would make the left side. And that's what we call the line of symmetry, or the axis of symmetry. And a vertical line has the equation of x equals. So we'll write down here, the axis of symmetry is x equals, and in this case, it's where x equals 0. That's what creates that mirror, splits the parabola exactly in half. And that's the most simple example of how you graph a parabola. In the next video, we'll do one more example, and we'll try a little bit more difficult problem. All right, thanks for watching.